Let's clarify some things related to function notation. Writing f of x equals 1 plus x squared describes a function. Let's work with this function. Say f of x equals 1 plus x squared. Be sure to say the word of. Though there is an equal sign, we'll say that f of x equals 1 plus x squared describes a function and not an equation. F of 3 equals 1 plus 3 squared. So you take a look up at f of x equals 1 plus x squared. We just replace every x with a 3. And then we can simplify this using the order of operations. 1 plus 9, 10. The expression 1 plus 3 squared was simplified, as I just mentioned, using the order of operations. In summary, if we skip the work just from the content to the left of the first equal sign and the content to the right of the last equal sign, f of 3 equals 10. The input is 3, the output is 10. We should write f of 3 equals 10. Writing f of 3 equals f of 10 is incorrect. Writing f of 3 equals f of 1 plus 3 squared is incorrect for really the same reason. In the parentheses, it's 10, and in parentheses, 1 plus 3 squared simplifies to 10. Here's another example. F of 4 is equal to 17. I skipped showing all the work. It is over here off to the side. F of 4 equals 1 plus 4 squared, which became 1 plus 16, which became 17. But I thought it'd be nice this time around just to see the summary form. F of 4 is equal to 17 first. So here, what this is saying is that when the input is 4, the output is 17. Here's another function. Given g of x equals 10x plus 3, evaluate g of 5. Now, what I want to do is start talking about some common mistakes in function notation. So the way to think about this is to write what's in this box, to write g of x equals 10x plus 3. That's really just copied from the question up here. But replace every x that you see with a 5 instead. I mean, and every x. There's an x right here, and there's an x right after the 10 as well. So there's the x in parentheses on the left of the equal sign, and there's the x right next to the 10 on the right of the equal sign. Replace every x with a 10. So take a look at what was in this box. It was pasted down here. Replace every x with a 5. Okay, simplifying using the order of operations, this becomes 53. So g of 5 is equal to 53. It is incorrect. Notice this sad face. It is incorrect to write g of x equals 10 times 5 plus 3 because the x that's right here before the equal sign wasn't replaced. So what's in this blue box up here is very literal. Replace every x with a 5. So given g of x equals 10x plus 3, same function as up here, evaluate g of n. Now, this seems a little strange because earlier in the previous question, we were given 5 as the input. Well, now we're just given a variable as an input. Instead of a number like 5 as an input, we're given a variable. So the overall thought process should be the same. So take a look at this blue box, right? G of x equals 10x plus 3. However, with one exception, replace every x that you see with an n. There happen to be two x's, one to the left and one to the right of the equal sign again. So a proper answer to this is g of n is equal to 10n plus 3. Okay, another example, another function. Given h of x equals 3 to the x power plus x squared, evaluate h of 4. Now, this one, people start to see a little bit more challenge to this because not only is there the 1x on the left side, but there's 2x's on the right side. And sometimes people get freaked out. What am I supposed to do? But really, the process is the same as we just saw earlier. So in what's in this box, which was copied up from the question, that's where it came from, replace every x with a 4. Now, unlike the previous slide where there was an x on the left and an x on the right, so a total of 2x's, now there's a total of 3x's. 1, 2, 3. Just replace all of the x's with a 4. When we do that, we get h of 4 is equal to 3 to the 4th plus 4 squared. Simplify this using the order of operations. So exponents first. 81 plus 16 is equal to 97. Writing h of x equals 3 to the 4th plus 4 squared is incorrect because the x before the equal sign wasn't replaced. Given h of, this gets more challenging. Given h of x equals 3 to the x plus x squared, evaluate h of s plus 6. So same deal here. Sometimes people try to get creative and try to distribute the h or something like that. But here, just take what's written, what the skeleton of this h of x equals 3 to the x plus x squared, and just replace every x that you see now with an s plus 6 instead. So over previously, the question in the top half of the slide, x was just replaced with a single 4, with a 4. It was a single character to write. Now x gets replaced with s plus 6, which is 3 separate pieces of writing, right? The s, the plus, and the 6. We just do that. So h of s plus 6 equals 3 to the s plus 6 plus then quantity s plus 6 squared. There are certainly other ways to write what's here after the equal sign, but we will see those things in some upcoming lessons.